Thank you, everyone. My name is PEDRO FORTUNA. I'm here to present Rhyming with Hacks. But let's set expectations right. I'm not singing today. Sorry, I'm not hip-hopping. But as a compensation, I have written a poem that you can follow along through some of the slides, and hopefully that will compensate. But later today in the social, if you buy me a couple of beers, maybe I'll sing. Let's see. All right, about me, I've been working with security for the last 15 years. I started more in the systems and network security side. Then very early on, I moved to bot detection. I worked in a few stuff. And more or less 10 years ago, I moved into the client-side security space, application security, code protection, and everything surrounding the browser and JavaScript security. So the agenda for today, I'm covering supply chain attacks. I'll cover the basics. Then we'll follow through existing solutions or approaches to solve web-based supply chain attacks. Then I'll cover the approach I've been working on in the last couple of years, and we'll conclude. We'll have a couple of demos as well. So let's start with supply chain attacks. So in the context of this talk, because we only have 30 minutes, I'm sticking to web-based supply chain attacks. It refers to mostly to third-party JavaScripts that somehow got compromised and now is injecting arbitrary codes in the same context as your client-side code. We could also refer or talk about compromised repos or compromised NPM packages. We don't have time for that today. So the context is web-based supply chain attacks. So like I said, compromised integrity of the client-side code, it means arbitrary code execution. Some examples of third-party scripts that usually get compromised are analytics, ads, customer support, plugins, live chat bots. There are a whole plethora of different browser vendor plugins that are getting compromised in the last couple of years. I'll talk about that a little bit later. And the consequences usually are data leakage. They usually insert what is called a web scheming or credit card scheming. They start leaking data and credit card information. They can also leak credentials. They can do things like crypto mining. Usually, it's around these consequences. So how does it work? So you have considered the first-party codes. You might have some scripts included in there. And those scripts are loaded from third-party vendors directly. You can have an iframe. You can load HTML. From that HTML, you can load additional code. So there's second level and third level JavaScript potentially being loaded. And also, JavaScript can pull additional JavaScript. So the level of dynamics it can be huge. So you have to account for this type of attacks. When something in this chain gets compromised, potentially your first-party code and application gets compromised as well. And what happens is they scrape the data they want to leak, and then they just send it to a drop server, usually in the third-party domain. So it's usually cross-origin. But one thing that is certainly possible is because they compromised a third-party server, they might as well just use that third-party server to exfiltrate data to on their way to exfiltrate it to a server controlled by the attacker. That potentially can be any domain. The biggest difference is that usually the vendor domain is already whitelisted because it's very common for people to just use CSP version 1 using white-based domain blacklisting. I'll talk about it in a second. The motivation for these attacks are, are easy to understand. It scales because they compromise the vendor, and immediately they compromise every website that is linking directly to that vendor. And with that, all the users that are visiting those websites. As a counterexample, consider, for instance, reflected XSS. When you find such vulnerability, you still have to somehow fool someone into using that crafted URL. And still you are only attacking one person. So it's a lot of effort compared with supply chain attacks where everyone basically is executing arbitrary JavaScript at the same time. It's also about, because of the weakest link are usually the third parties. So you consider big companies having security departments, and sometimes they use third parties that are small companies with a huge lack of resources, probably just one or two guys handling all the security. So it's hard for them to cover all the angles, and it becomes very attractive to attackers. These attacks are also known as mage cards. We think that mage card comes from either magazine, which is the Russian word for store, or because most of the attacks, or a huge chunk of those attacks, are Magento installations that are compromised. And so mage card might be based on that as well. So it started with a single group back in 2015. And right now we have dozens of different groups just following slightly different approaches with slightly different schemers. And it kept evolving. And since last year, the sophistication of these attacks have been growing a lot. What they do is as I said, they perform digital credit card scheming. Some people call this form jacking, although there's not a consensus about what terms should be used. And they do this because there's a whole economy behind this. So once they scheme the credit card data, they have elaborate ways of just purchasing products, and then either they usually reship the products to their countries, the attackers' countries, and then they sell the products, or they just sell the credit card information on the dark web. So we don't have time to cover many of the attacks that have been going on today. So I'll just highlight a few of the attacks and what they have in particular, to my opinion. So it started with jQuery early on in 2014. For a few hours they were infected. They were serving a rig exploit kit. That was probably not the first time, but the first time it was really visible to everyone in the community. Then last year, the Ticketmaster attack, it lasted for 5 months. 5 months exfiltrating credit card information without being mitigated. So I think it's concerning. The British Airways was also very referred, and it's different from the previous ones because in that case it wasn't a third party that got compromised, but rather the first party code. So they were able to breach into the network of British Airways and compromise the code directly on the server. Another example, more recently this year, Advertline, which is an ad company, was compromised. And what's particular about this attack is that their web schemer, the web schemer that was used in this attack, was very sophisticated compared with the previous versions. So it actually had anti-bot defenses. So if people are trying to see if the schemer is doing certain things using automated mechanisms, they are trying to spot if such mechanisms are being used, and then they just prevent themselves from executing in those moments. And therefore they avoid the problem of being detected. They also use integrity checks, so if the code is modified, they prevent themselves from executing. and they check if the browser debugger is open. They check a lot of stuff. So clearly, the sophistication of web skimmers is on the rise. This month, we had also a series of supply chain attacks that compromised a few vendors. And so usually, historically, they only collect the fields from forms they care about. But now we started seeing a different behavior where they are basically collecting every form field they find in the page. So it's just an example to see how fast they are adapting and doing different stuffs. We also have examples of compromises that went after the crypto exchanges keys, and yeah, so there's a lot of things that are going on, and unfortunately we don't have time to go through all of this. So let me show you the anatomy of one attack. This is the Inventa web skimmer. So Inventa was the vendor that got compromised in the Ticketmaster breach last year. This code is obviously obfuscated, but the obfuscation is very weak. So it's very easy to, after a few minutes, to get nicely indented code that you can understand very quickly. And so usually what it does is checks if the code is running in a certain URL that contains these keywords like order or checkout or one step. Then they just hook into a few elements that they can find in the page. You can see up there, if they see a button or an input, they hook into those elements. They want to listen for, they want to install the event listeners like the click and on-click. Then they collect, once this function is triggered, they collect all the information belonging to those elements. They replace the onSubmit event, and eventually they send this data to the drop server, and this code is executing every 30 milliseconds. Right? So it's pretty simple to understand. And now I have a demo of one web-based supply chain attack. It's actually an emulation. So this is a Ticketmaster website. It's not the real web skimmer that is running. We actually implemented our own drop server. And as you can see on the left, we are running this. And we are injecting directly the skimmer in the page using browser extension. So we are starting the drop server. So it's just waiting for credit card information to be sent. And we are doing purchase. So please bear with me. I actually accelerated the video a little bit, but maybe not too much, so don't fall asleep. Okay. So this is what the user sees. It's just filling out the form and ordering tickets. And then at the very end, the code exfiltrates the data to the server, and you cannot possibly see that happening unless you're looking at your network settings or something like that. All right. So let's get into the existing solutions that we see in the market. We cannot go very deeply into every solution, but we'll cover the majority. But starting with very quick fixes that you can implement. So probably the most efficient fix, at least if you're concerned about third parties, is simply not including the third party in the pages where you're handling sensitive information. So for instance, why would you need, I don't know, live chat in your payments page? Maybe you don't need it. So you can remove that live chat from that page and just leave that third party on different pages where you are not collecting credit card information. So another one, hosting the files yourself. so some companies do this. The problem with this is, well, first parties can still be compromised. There are a few things that you can do, but you are basically assuming this responsibility, and there's the problem of dragging behind in versions, because now the vendor cannot update the code every time he wants, which, if you ask me, it's a good thing, but they don't think so. So vendors usually don't like this. You can also try to roll out like file integrity, read-only file systems. You can try to check refresh the system every once in a while to make sure that hasn't been tampered with. No one has been able to breach the server and modify the files on the disk. But this type of solutions, they get complicated very fast. You can also consider using sub-resource integrity. If you are not familiar with sub-resource integrity, it allows you to set a checksum for the scripts being loaded using an attribute. The problem is, what I already mentioned, is that the third parties don't want you to do this. They simply don't want to lose the ability of updating the file that you're using and deal with the fact that a lot of their clients are dragging behind in versions. So they just force you to load the file directly from their servers, and you either accept that or you don't. So obviously, it doesn't cover the self-hosting. You can use sub-resource integrity with your own files, and probably you should. It's one way of maybe mitigating the problem if your server was compromised. But surely, if they can, if they compromise the system, maybe they can just remove the tags, and then everything just falls off. You can also do domain sinkholing. Usually, this technique requires some sort of monitoring system using a server-side rendering. So every once in a while, they start polling the website and pulling out the data and code that is being executed. They execute that code, but then at a certain point, the third party or the website gets compromised through a third party or something. And what they do is they have signatures that try to match malicious content or malicious code. And if they detect malicious code, what they do is they simply update the DNS entry because they find out what's the drop server domain, and they update that domain to basically a null value. And what happens is that everyone that's using that DNS information will not be able to, so the exfiltration will not work. But the problem with this approach is that there are a few problems, actually. The thing is, first you need to ingest this threat intelligence information. So you either are consuming this information and get mitigation, or it doesn't work. But there are a few other problems. The whole approach is based on signatures, which means that they're looking for things, and sometimes, a lot of times, that fails. And that was the case with the British Airways. So the attackers, in that case, they changed the skimmer code, and the signatures failed to detect this in real time. So eventually, they noticed, but they couldn't mitigate the attack. And the thing is, you cannot possibly predict how the web skimmers are evolving and have signatures that will always work, because the attackers can always obfuscate the code in many different ways, and it's very difficult to work. Obviously, you can, I already mentioned this, you can use CSP, but the problem is that every solution I know is using first generation CSP, so they are blacklisting domains. And that doesn't work because there are many bypasses. Even Lucas mentioned that in his talk earlier today. And I actually have a quote from your research, Lucas. And the problem with that is that, like I said, schemers can start using the third parties that are compromised, if not one of the many bypasses that CSP version 1 has. So that CSP doesn't work to prevent exfiltration of data. This is a fair warning. So there are too many ways of accomplishing that. And so you should probably consider other solutions as well. All right, so the last one is based on what I call JavaScript virtualization. There are different solutions out there. This is my understanding of like the typical solution based on this approach. So you need to use some sort of library, JavaScript virtualization library, that needs to run first. And then what it does is it changes some methods that are used to add code to the page, like the examples that you're seeing. So these methods become proxied, and this gives you a certain level of security because, like I said, the assumption is that our library has executed first. And so when you load the third-party lib, what happens is it will use one of the proxied methods, and then what the library does is it runs that code in a sandboxed iframe that is cross-origin. So hoping for that to get some isolation and whatever malicious things the code is doing, it will do it in a sandbox environment. But the thing is, they need to screen the behavior of this library because somehow they need to propagate what the library is doing to the main window. Otherwise, that code is not doing anything. So they either allow the behavior or disallow the behavior. And if they allow the behavior, they will need to sync this behavior to the main window. And that's basically how it works. So the main problems I see with this is that the whole thing is super tricky to accomplish. It can break the application actually because it needs to, all the events that are synchronous need to be also synchronously propagated to the main window, and that is impossible to do. So that has the potential of breaking the application or just creating racing conditions, and this is to the best of my knowledge, of course. Also, it doesn't seem to be another way of doing it, but by duplicating the DOM in the sandbox iframes. So if we start digging, we'll find other problems. So in a nutshell, it's super tricky to accomplish. In my opinion, it can easily break the third-party application. And also, it's a problem to know what's like the normal behavior of the third-party library. Because that behavior can change over time, so it's hard to keep up. It's hard to know whether or not a new behavior should be allowed or not. So it's a very complex in general. All right, so we are ready for getting into the web page integrity. This is a new approach that we have been working on in the last couple of years. It can be used to try to mitigate web-based supply chain attacks. Let me explain how it works. So on the client side, you have all these different elements. You have the DOM, you have JavaScript APIs, you have event handlers, you have first-party and third-party JavaScripts. But with web page integrity, you also have these extra JavaScripts that we call real-time monitoring agents. So it doesn't look or monitor the first-party or third-party code. All it does is monitors the other elements. So as you can see, it's periodically looking to the DOM and all the other things that you can see there. So, so it's based on mutation of servers, and it has a few checksumming techniques built in and poisoning detection techniques. And it assumes that it's running in an environment where malicious code is running alongside of it. So once first party or third party gets compromised, the first thing that it can do, it can go after the DOM by changing it. maybe modifying a form, maybe inserting elements, I don't know. The other thing is it can poison JavaScript native functions or event handlers to be able to scheme information out. It can also go after our codes, but that's difficult because it's everything that we have out there is protected with tamper-resistant polymorphic code. This is a mouthful, I guess, and I don't have time to explain it all, but it's basically obfuscated. It has tamper integrity checks, so it's checking if it has been modified. And from request to request, the code changes completely. So if the attacker tries to automate some attack against that code, it's not impossible, but it's difficult. So what we do once we detect something is off, we try to heal it, we try to annul it. So if we see some injection in the DOM, we try to remove that injection if possible. If we see poisoning, we try to remove the poisoning and fix it, or prevent it in some cases. So it also has a server component, so we send this information back to the server, and this information is then compared with historical data, and if we think that this is malicious, we send it to the backend of the application through a webhook. So this means that the application is continuously hearing a stream of events that are happening on the client side. And this is good because then you can set additional reactions or policies on the server side, and this is done in real time. So if you just hear that anyone just tampered with a form, then obviously we try to mitigate it, but if we can't, you can always do additional measures to try to deal with that. And you can adjust what is happening on the client side based on that information. So we have a second demo, very quickly. So it's the whole thing again. So we are redoing the same demo, but now with the agent is being included as well. So we start the drop server. Let me try to speed this up a little bit. Okay, so this is the dashboard of the solution. So it's currently empty. And now we are just purchasing tickets. Let me speed this up a little bit. All right, so you see, you can see that something is happening in the back. So this is the dashboard again, and it just detected some poisoning. And this is the information that we detect, and we can show you basically the schemer code that was detected. A countermeasure could be executed at this moment, but in this demo we are not doing that. And then at the very end, you will see that what happens with the drop server. All right, so finishing the purchase, and it says form jacking mitigated. So basically, we prevented that web schemer from successfully poisoning the form, and we prevented the information from being mitigated. All right, to conclude, so web-based supply chain attacks, they usually go for the weakest link. They usually find smaller vendors or enterprise with no security in place or no real security in place to be the weakest link. They scale. This is a huge problem since last year. I'm seeing a race in the market, so a lot of companies are just rushing to get some kind of protection. There's a lot of confusion around the solutions that you see out there and their effectiveness. And I think this is a business problem, actually, because if your company ends up on the news but because your customers' data was somehow exfiltrated, this is very concerning. I don't think it's a very hard problem to solve, so we should consider the solutions. And we should also consider that schemers will evolve, will become more sophisticated and start doing tamper detection, anti-bot, and whatnot. And so in our approach, in my opinion, it's it's simple, it's efficient. You don't have to do the whole thing of just marshalling the events to iframes. It doesn't break the code because it's not changing anything about it. It's kind of holistic because not only detects this kind of threats, but also can detect XSS and other types of tampering from malicious extensions, for instance. And it has also is already protected with the JavaScript code protection. Obviously, I'm not saying this is invincible, nothing is, but it raises the bar a little bit and makes it harder for the bad guys. So in the end, it's always a arms race, but that doesn't mean that you shouldn't do anything. All right, so last but not least, I recommend this white paper from RiskIQ inside MageCart. It's a pretty substantial write-up. I find it very interesting. And you have a couple other references that you can read if you are interested in this topic. This is all I have. Thank you. If you are interested, grab the full poem using that link.